So class, now let us learn about derivatives of inverse trigonometric functions. And on the screen you have a given problem, and this given problem is not in the simplest form. So whenever you have a problem which is not in the simplest form, what we do is we simplify it. Because when you simplify it, you can easily find the derivatives of that function. Now, to simplify it, we use trigonometric functions. So we start with let tan inverse x is equal to theta, which implies x is equal to tan theta. Or you can start with let x is equal to tan theta, which implies tan inverse x is equal to theta. Either way, it is true. Now, focusing on the screen, you have tan inverse x is equal to theta. So remember, it does not mean that you are transferring tan inverse to the right side and then you have tan theta. It does not mean like that. But when you say tan inverse x is equal to theta, and for this equation to be true, x should be equal to tan theta. And after you have done that, then y will be equal to 2 times tan inverse x, and that is in the simplest form, and you can easily find the derivative of 2 times tan inverse x. So we differentiate both sides with respect to x, and when you say with respect to x, means you should have dx in the denominator. And here 2 is a constant, so 2 you can take it out from the given function, and then you will have just 2 upon 1 plus x squared. So that is how inverse trigonometric functions can be solved. Also, note down the graph of cos inverse x. Here, x should be any number between -1 and 1. Anything inside the bracket of cos inverse should be a number between -1 and 1. Note down, because that is very, very important. So any expression, any algebraic or any polynomial functions inside the bracket of cos inverse should be a number which is less than 1 and greater than -1 or greater than 0. So we are sure that in this given function, in the second line, that expression inside the bracket is less than 1 and greater than -1, because they have mentioned on the right side that x is less than 1 and greater than -1. Or you can say that x is less than 1 and greater than 0. So that expression inside the bracket of cos inverse is very sure that it lies in between -1 and 1 or 0 and 1. Also note down, when you differentiate both sides with respect to x, that means when you have dx in the denominator and you are not having cos x, instead you have cos y. So x and y, they are variables, and cos y is not a constant. So what you do is you use the chain rule.